Zoom recording. Okay. All right. So this is the second class of machine learning for healthcare. And okay, so we'll do some recaps first and then get to the main material. By the way, so can everybody hear me okay? All the internet connections, all good? Is there any problem? No? All good to go? All good to go? Chat, okay. Perfect. All right, cool. Good. So if you see any problem or if you can hear me during the class today, please message or whatever. Just hit me or ping me. All right. Okay. Good. All right. All right. Okay. So welcome to the second class of machine learning for healthcare. So class 1 recap. So a very brief recap of what we've learned or what we've done last Tuesday. So in the last class, we talked about the broad industry of healthcare and that there are countless opportunities. And unless we start talking to a lot of experts from different segments of the healthcare industry, we won't be able to find them. And then we also talked about deep learning, how its performance comes from the combination of big data and powerful compute, such as GPU or TPU, which leads to less feature engineering and also great performance. So that is why it is the kind of the standard these days. By the way, how do I turn this off? Okay. And so yeah, and then when the reason that we want to combine healthcare and deep learning is that the data is ready. The healthcare due to electronic health records, large hospitals or government has been collecting a lot of records. So the data is ready, the algorithm is ready, and the hardware is all ready. So we just need to find the right opportunity, the right application to revolutionize the healthcare industry. So let's change healthcare and let's also save costs and save lives. So that was the gist of last class. Okay. So quiz 0, yeah, and a brief recap of quiz 0. So as far as machine learning knowledge, so there were 10 questions and one a very simple question related to how familiar you guys are with TensorFlow and PyTorch. So as far as machine learning knowledge goes, generally Naver engineers were less familiar with basic ML, and we'll go one by one with the questions so that I can give you more correct answer. So if okay, I'm gonna open the quiz now. And also the feedback. All right. So can everybody see the screen of the quiz, or is it just the PowerPoint that you guys are seeing now? Oh, still PowerPoint. Okay. New share. Oh, okay. I can just share my desktop. Okay, now can you guys see my screen? Yeah, the Safari. Okay, cool. Yes. Okay, good. All right. So there were 10 questions, and the last question was multi-answer type questions. So I will go just one by one. I don't know how I can put it here. Okay, right here. Okay. So what is the difference between supervised learning and unsupervised learning? So a lot of you were pretty much correct, but the one thing that I want to point out that is some people said that the clustering, some people seems to think that the clustering equals unsupervised learning, but that is not true. So supervised learning, as a lot of you have said, is training with basically a labeled data, and unsupervised learning doesn't require labels. So clustering is one example of unsupervised learning, but also, for example, autoencoders don't require labels because autoencoder is just reconstructing the input from, so autoencoders consume the input and try to reconstruct it on the output side. So it doesn't require label, it just needs data. And also generative models don't require labels, such as VAE or GANs. They don't require labels because it just needs a lot of data, and then it tries to reconstruct its own input in some manner. So both like GANs or VAEs or even clustering, they can all be called unsupervised learning. So that's that. And then the second one was, what is a gradient descent? So that also a lot of people, oh, is there a question? No, I heard the mic. So, okay. So a lot of people were familiar with gradient descent. So it's basically an optimization algorithm to find the local minimum or global minimum of a given objective function. But some people were kind of blurry with the technical difference between GD and SGD, which is stochastic gradient descent. So the basic difference between GD and SGD is that GD uses the gradients of all data. So like back in the classical ML days, there is no mini batch. You have, your data is not that big, so you can you can load your entire data on memory and then calculate the gradients of using all the samples, and then average the gradients to update the parameters of your model. But these days the data set are huge, so you can't really calculate the gradients of all the data at one like iteration. So you slice them up and then you put them into like a subset of. Is anybody talking? No. Okay. So yeah. So as I said, because of the big data era that we live in, we can't really load them all up in the same memory, and we can't basically calculate the gradients of all the samples at the same time. So we slice them up and then we put them into different bags or mini batches. So that's the different. So in GD you use the gradients of all the data for one update of the parameter. In SGD you use, basically it used to be just one sample. You use the gradient of just one sample for one parameter update, but that is too noisy. So SGD is still a unbiased estimator of the true gradients, but you just estimate it with a subset of samples instead of the entire samples. So it could be noisy. So it's unbiased, but it has high variance. And the less sample that you use per update, the higher the variance. So there's a trade-off. If you have a higher variance, if you use a high variance gradient, there's a chance that you might like escape the local minima or saddle point, which is just, okay, so this is just like basic, like fundamental ML knowledge. But basically what I'm saying is that if you use a smaller batch sample, there's a chance that you get a better final outcome, but it's going to be slower because you're using like a estimate of the gradient instead of true gradient. So people don't use just one sample at a time. They use like a mini batch of samples, such as like 128 samples or 256 samples. Or these days, when people train transformer or BERT, they use like thousands of samples. Okay, so that was that. And the next one was, what is the curse of dimensionality? So people, I guess some people were pretty accurate about what curse of dimensionality was. Some people don't know what it is at all. Some people were confusing the size of that. Curse of dimensionality was not, it doesn't have to do with the parameter of the model. It has to do with the feature space. So the dimensionality, the dimensionality that we're talking about here in this particular curse of dimensionality is the size, the dimensionality of the input. So it's not the dimensionality of the model weight. So there's a very nice illustration from, from PRML, pattern recognition and machine learning, which is the Bishop book, the very famous Bishop book, and you can see what it means what it means to have or suffer the curse of dimensionality. So, for example, let's say your input is just one scalar input. So there's just one dimensional input. Your features are basically, there's only one feature. per input, which is just a scalar value. And you want to classify them into different segments. Like if your input is between 1 and 5, then that is class 1. If your input is between 5 and 10, that is class 2. And if your input is between 10 and 15, then it's class 3. That's basically what we're trying to do here when the dimensionality is 1, right? So you only need to see basically 3 samples to correctly identify 3 classes. Just 1 in here, 1 in here, and 1 in here. So 3 buckets. But if you start using 2 features per sample instead of 1, so then it becomes this. So there's feature number 1, x1, and feature number 2, x2, and now it is 2-dimensional. And let's say that both features can take the value between 1 and 15, and you want to segment them up. You want to slice them up again in the same manner. And then now you have 9 grids to fill in. So you need 9 samples. You need at least 9 samples to correctly identify each class, or correctly identify, correctly identify each class or each sample. So for example, let's say you have a point in here, point in here, and point in here. Point in here, and point in here, 1, 2, 3 here. If you have only 3 samples, then you're missing out 6 possible grid, and you need that much more information. Before, you only needed 3 samples to see the entire feature space, but now you need 9 samples in each grid to see the entire feature space. And if you blow it up to dimension 3, so you add 1 more dimension, and then there's dimension 3, x3 here, and now it's a cube instead of a square. So now you need 3 times 3 times 3, so which is 27. So you need 27 samples to fill each grid and see the entire feature space. So what it means is that what recursive dimensionality means is that as you linearly increase the size of the features, or as you linearly increase the size of the dimension of your input, you're actually exponentially increasing the feature space. So that's what the recursive dimensionality means. All right. By the way, if you have any question during my talk, just raise your hand, or type in the chat box, or anytime. I want to make this as interactive as possible. All right. So what is overfitting, underfitting? People seem to tie the notion of training time with overfitting and underfitting. A lot of people seem to do that, but that is not necessarily true. It is one case of overfitting, underfitting. So if you train your model for too long, and then it starts to memorize the training samples, and it doesn't generalize to the test samples, that is one way of seeing overfitting. So if you train, but but overfitting doesn't necessarily mean that you're so the essence of overfitting is not the time you spend on training. It's the capacity of the model. Let's see if I can find a very nice picture here as well. By the way, I'm using this book without the consent of the author, so please don't share this video. What? That is weird. I think I saw a nice picture somewhere. Okay, so so let's see. Okay, I think this is a nice picture. So let's say your data, the samples that you were given to fit your fit your function is these blue dots here. So these are the blue dots, and then you want to estimate a polynomial function to fit those data so that you can either impute, or you can predict the future. Like you can predict for example, if you were given like a red dot here, then you would like to predict that it is like a continuation of of this function, or if it's an anomaly, something like that. So you can use either a so this is what this is a third degree polynomial function. So you can either use a third degree polynomial function, or you can use either, I don't know, 15th degree 15th order polynomial function to fit these samples. And intuitively, so the green line here is when you use the third order polynomial function, and the red line here is, I don't know, it could be like 15th order or 20th order or whatever it is. Which, what I'm saying is that the red line is coming from a function that is way more expressive than the green line, because the green line can only use up to third order polynomial, but the red order, let's say, it's like 15th order. So 15th order is way more expressive, or it has higher capacity than the third order polynomial function. But you can see that it is kind of like overfitting. This is the essence of overfitting. You want your model to have a good generalizability, which is what the green line here is demonstrating. But here the red line is so expressive that it's just overfitting to the samples. So it doesn't seem like a good fit. I mean, intuitively, when you see this, like there's like a lot of curves that are unnecessary. So then you will see that the red line won't really generalize to unseen data. So this picture here is the essence of overfitting. So it doesn't necessarily mean that you've trained your model for too long. It means that your model is so expressive that it has trying to memorize every single sample from the given training data. So, which is not good, because then it won't generalize. So classically, the way to overcome overfitting is to either use more data. So here, this is a good example of when using more data, your data doesn't overfit. I mean, your function doesn't overfit. So now we've added a lot more blue circles, and then when you use the same third degree polynomial function, it stays the same, because it has limited capacity. So it was already fitting nicely when there were only 15 samples, but now that we're using 100 samples, the green line is still staying the same. But now the thing to notice is that the red line, which was, I forgot, I think it was, okay, it's 9th degree polynomial function. So red line is coming from a 9th degree polynomial function. So we're trying to fit 9th degree polynomial function using either 15 samples or 100 samples. And when we're using 100 samples, the red line is showing a better fit compared to when we were using 15 samples. So now the red line is not overfitting, because we've used more data, and it will generalize better. So that is one way. One way of dealing with overfitting is using more data, or we can regularize our our model. So when we use, I won't go into detail what regularization is. Actually, no. Here's another PRML Bishop book is such a very classical, nice book. So you can learn a lot from this. So what is happening in here with a 9th order polynomial function, when we're using only 15 samples, the coefficients of the polynomial function, the red line, because it's a 9th order polynomial function there. So there's like x to the square, and x to the 9th power, x to the 8th power, x to the 7th power, x to the 6th power. There's like a lot of powers, and there are a lot of coefficients in front of those powers. So you can see that the weights, so these are the weights. So there's weight number 9, weight number 8, weight number 7, weight number 6, which is the parameter that you use for the 9th order polynomial function. And it is the values are extreme. In order to fit very accurately to these 15 samples using 9th order polynomial function, the coefficients are huge. Like the value of the parameters are just humongous. It's like 10,000 or 100,000, even like million. Like this is negative 1,061,800 for, what is it, for 6th degree polynomial, sixth power parameter. So, and we want to prevent this from this from happening, these humongous values. So what we do is we usually regularize with L2 regularization or L1 regularization. What we're basically trying to do is we don't want the values of the parameters to shoot up to be this extreme. We want the values of the parameters to stay within like a reasonable range between like 10 and -10, or like 5 and -5, something like that. Because when you use sixth order polynomial function, it is staying relatively in the reasonable region. It's 25 and 17. But if you use N9 and it's trying to fit all the nooks and crannies, every single sample of the given training data. So it is why it's shooting up. So we want to, when we try to regularize the values of the parameters, it'll behave more reasonably. So it'll stick more to the like this, like the red line here. So as I said, two ways to deal with overfitting is you either use more data or you regularize your sample, regularize your model. All right. So, and underfitting is basically some people said that the underfitting was like the opposite of overfitting. Like overfitting, your model doesn't generalize to unseen cases test data, and underfitting, it generalizes well to test data, but that is not true. When your model is underfitting, you don't really need to talk about the generalizability because your model hasn't learned enough. Your model hasn't sufficiently learned to fit to the training data. That is what underfitting is. So here, if you are using, so if you are given like 1, 2, 3, 4, like 10 samples here, and you're using like a line function instead of a third order polynomial function, then your model is underfitting because your model is so incapable, or it has like a limited capacity or expressivity. So that is why your model is not really fitting to the given data. So that is what's happening with the line function here, with the red line here. It's basically, it's not expressive enough to contain the general pattern of the data. So that's what underfitting is. So so I just want to emphasize one more time that it doesn't necessarily have to do with the training time of your model. It's just the capacity of your model that is at play here. All right, and the precision and recall, precision and recall, a lot of people were already familiar with precision and recall, so I'll skip that. One thing that is kind of interesting is that precision and recall comes from information retrieval, not the machine learning. Well, yeah, it is used more frequently in information retrieval, like when you want to retrieve a relevant document to a given query, then you want to like retrieve a document that is, you have like basically like millions of documents. You want to retrieve a very small number of documents that are relevant to the query. So you measure that by like precision and recall instead of accuracy. Accuracy means that whether you've like predicted or classified the sample accurately. So it's not a, so it's used when your classes are balanced, like there are like 50 samples of dogs and 50 samples of cats, then using accuracy is okay. But when there are like millions of irrelevant documents and only like a handful of relevant documents, then accuracy is not a very good measure. So that's why in information retrieval, people use precision recall or a combination of precision and recall, which is called F1 score. All right. So linear classifier and nonlinear classifier. Linear classifier means that I guess I could talk about this in the future courses, but basically linear classifier means that you don't mix between the the features of your samples. So let me find the cursive dimensionality again. Yeah, here. So this is when you're using one feature. This is when you're using two features. This is when you're using three features. And basically, linear models or linear classifiers don't model the interaction between. For example, let's say you're using 3-feature model. Like your input is coming with 3 features, x1 and x2 and x3. And if your model is linear, that means that you're not modeling the interaction between x1 and x2 and x3. They play independent rules. And if your model is nonlinear, that usually means that you're modeling the interaction between these x1 and x2 and x3. So Non-linear classifier, basically it's a logistic regression or linear regression, that and non-linear, or even support vector machines with linear kernels. So those are like good, or perceptrons with linear, like linear perceptrons are also linear classifier. And non-linear classifier, the a representative example is a tree or even random forest. They're a very classic example of non-linear classifier. Or if you're using like a polynomial kernel or radial basis function kernel, RDF kernel, Gaussian kernels in your support vector machines, then your SVM is no longer linear, it's non-linear. And some people wrote that clustering is a nonlinear classifier, but clustering is not technically a classifier. It's a unsupervised learning method. So I guess you can do classification with clustering, but people don't usually do that. So clustering is not a classifier technically. And even if it was, k-means clustering is not a nonlinear classifier. So what I'm saying, so some people answered that an example of linear classifier is logistic regression, and an example of nonlinear classifier is a clustering. And I'm saying that the clustering is not actually a classifier. And even if it were, for example, k-means clustering is not a nonlinear method. K-means clustering is a linear method. It's a linear clustering method operating in a Euclidean space. So I want to get this right. All right. And what is a margin in support vector machine? So a lot of people were kind of familiar with the concept of margin, but very few people were technically correct. So I want to emphasize that. I wonder if I can use a blackboard or like a whiteboard or something. Annotate. Draw. Oh, okay, this is nice. All right. So undo. So here is a two-dimensional plane, and there are one class of examples here, and there are another class of examples here. And you are separating these two classes. Okay, this is not a good hyperplane. You're separating the two classes with a hyperplane that looks like this. All right. And the objective of SVM, support vector machine, is you want to separate, you want to draw. There can be a lot of lines that separate these two samples. For example, there could be line. How do I make this color? All right, so here. You can draw a line like this, or you can draw a line like this, or this. I mean, there can be millions and millions. Okay, this is not good, but still, like, okay. So there can be infinite number of lines that separate these two classes, but the best line is in the philosophy of support vector machine. The best line to draw between these two classes is the one that maximally separates the two, which means that all right, I need to undo all these red things. All right, so the best line to draw to separate these two is the one that maximizes the margin, which is the distance between the closest sample to the hyperplane. Like this. So, for example, this margin here is larger than this one, so we don't care about this. So we only care about the samples that are closest to the hyperplane, and we want to draw the line that maximizes so margin. So okay, so let me define what margin is. Margin is the distance between the closest sample to the hyperplane and the hyperplane. So the red lines here is the margin, and we want to maximize the margin. So that means that we don't care about the distance between samples like these or these, because they are farther away these three samples are farther away from this sample, from the hyperplane. So we don't care about that. So we only care about the margin, which is the distance between the closest sample to the hyperplane. And of course, we want to draw a line that makes the margin from both classes equal. So we want to draw a line such that this line here, and I mean the margin here and the margin here is the same. And that is what the margin is. So the margin is not the distance between two samples. Some people said that this is the margin here, like distance between x and O. That is not a margin. Margin is the distance between hyperplane and its closest sample in either classes. So that, and the reason that we want to maximize this margin is there's if some people are familiar with VC dimension, like learning theory, statistical learning theory, it means the reason that we want to maximize the margin is because it guarantees a generalizability, basically. So when we draw a line that maximizes margin using the training data, then this hyperplane will perform equally well in the test data. So that's what like the VC dimension and all the statistical learning theory guarantees. Larger margin means better generalizability. It is proven. So that is why SVM was like such a big hit in the mid 90s. SVM came out in 95, and then 98 there was like a soft margin SVM. I forgot the name. Anyway, so yeah, in 95 there was a hard margin. And then the follow-up version of SVM came out in 98, and then it was like a big hit during the early 2000s, mid 2000s, and then ever since deep learning came out, like SVM is old. It's old news now these days. All right, so that's the definition of margin. All right, clear. All drawings. All right. Okay, and then the next one is how do you set the K in k-means clustering? This is a lot of people already knew the answer, so which is great. You basically do the k-means clustering. The K is the number of clusters. That is why this method is called a k-means clustering. You want to cluster your data into like either 3 clusters or 4 clusters or 5 clusters, and you need to define the number of clusters beforehand. So that is, it's kind of well, it's not a very intelligent method, but still people use it a lot. If you have a good intuition of how many clusters there might be given your data, then you can set that to a number that you think it is appropriate. Or you can do trial and error. You can start with 1 cluster, 2 clusters, 3 clusters, 4 clusters. Like you can increase the number of clusters and measure the fit of your cluster to the data, and just select the one that best fits your data. And fitting means that like you can see a nice, like if your cluster contains a pure, like a homogeneous group of samples. So you can do that with trial and error. Okay, so the next one is, what is a vanishing gradient in neural networks? So a lot of people already knew what vanishing gradient. Interestingly, a lot of people don't know what cursive dimensionality is, but then they know what vanishing gradient is. So it's pretty interesting. We live in a time of deep learning, so I guess that is what we're seeing these days. So vanishing gradient, a lot of people already knew what this is, but some people were confusing what vanishing gradient is. Okay, let me annotate one more time. So when you're using a multi-layer neural network, and there's like a classifier like a 3-way softmax classifier, and then you have your feed forward network looks like this. So, or it could be a recurrent neural network. Like there could be like recurrent loop in each layer as well. So, and then you have an input X. So so vanishing gradient is so I think a lot of people are already familiar with what backpropagation is. Backpropagation is that you have a sample of X and the label Y. For example, this is an image, and this doesn't look good. All right. So this is an image of a person, and you want to classify. So this is 3-way classifier. So this is human, this is a dog, and this is a cat. And of course, Y here is human. So you put this into you put the image to the classifier, and then it'll manipulate the images layer by layer, and then finally it'll say like let's say it said a dog instead of a human. Then there's an error. So you start back propagating your error signal back to the input all the way back to the input, because there are parameters here, parameters here, parameters here, parameters here, and you want to update your parameters, parameter set 1, parameter set 2, parameter set 0, 1, 2, 3. So you want to update these parameters by backpropagating the error signal. So here, the error signal is pretty direct. So this classifier predicted that this image is an image of a dog instead of a human. So there's an error. So you calculate the error, and you can update W3 directly. But then in order to update W2, you need to use a chain rule from like all the calculus back in the days. And you can indirectly update W2, and then you use chain rule again, and then you indirectly update W1, and then use chain rule again, and then you update W0. And as you apply chain rule, the norm or the size of your gradient could start to diminish. So if the norm, I forgot the exact condition, I think it was that if the eigenvalue of your gradient or norm of your gradient was less than 1, then as you apply more chain rule, it will start to diminish to the point that the size of the gradient becomes 0. So the way that you update your parameter is so for example, your new parameter is usually old parameter plus a step size times a gradient of your parameter. So you use your gradient to update your parameter, and if the size of your gradient is 0, then basically you're not updating anything, because this term becomes 0. So when your size of the gradient becomes 0, that's very bad, because your model is not learning anything. All right, so you want to prevent that, but it could happen, as I said, under certain conditions. If your gradients, like I think it was eigenvalue, if your eigenvalue of your or largest eigenvalue of your gradient, something like that. It's like something to do with the norm or the eigenvalue. So if that condition is met, then when you use multiple chain rules, then your gradients will eventually become 0, so that you can't learn anything. So that is what vanishing gradient is. So that is why before like 2012, like before I guess, to be technical correct, before the birth of ReLU, people were not dealing very well with vanishing gradient, because like when people try to use more than 1 hidden layer, like 3 hidden layers, 4 hidden layer, 5, even like 100 hidden layers, it is guaranteed that your gradients will either vanish or explode. So exploding gradient is the opposite of vanishing gradient. So it can go, the size of your gradient becomes like infinity as you apply more chain rule down like multiple layers of neural networks. So that is why before like the birth of deep learning, people always they used to stick with only 1 hidden layer. So they only use 1 hidden layer because they couldn't deal with vanishing gradient or exploding gradient. But now we live in the days of deep learning, so we can use residual connections or batch norm or ReLU, or we can do like greedy layer-wise updates. We can use all kinds of techniques, and we can blow up our size of the layers to like 100 layers or 50 layers, 150 layers. So I think I've seen even like 1,000 layer neural network, and people managed to train that. So all right, so that's the vanishing gradient, and some people were confusing vanishing gradient with the size of the weights, not the gradient. So vanishing gradient it relates to the gradient of the weight. It's not about the weight themselves. The weight don't go to 0. It's the gradients that go to 0. So I want to clarify that. All right. So that's the so that is the recap of the quiz. And so lastly, TensorFlow and PyTorch knowledge. A lot of people, like I think about 85%, 90% of attendees all checked here that they have some basic training. They have gone through the tutorial and trained a model and then evaluated the model. Very few people said that they can replicate a model from a recent academic paper. And so, yeah, I think only like 3 or 4 people are in this region, and all the other people are in this region. So I don't want to make this course a training course for how to use PyTorch or TensorFlow. So I'll try to keep the assignments as easy as possible so that I don't have to spend time teaching TensorFlow. And also I don't want to put a lot of, like, I don't want the attendees to suffer by going through like massive examples of TensorFlow and PyTorch. I mean, it's good to learn them on your own, but yeah, but this class is not about designing like advanced model using TensorFlow or PyTorch. And already, and a lot of like popular models are already in the library, like VAE, ResNet, Confluent, they're already there. So you just need to call them and then use them. You just need to call the API. So yeah, unless you want to build every single model from scratch using AutoGrad and like C++ operations, I don't recommend going too deep down into TensorFlow or PyTorch. But I mean, if you want to like develop a state-of-the-art machine learning model, then you need to do that. But if not, if you're just interested in like applying well-known models or tweaking well-known models to like very limited extent, then just going through tutorials is okay, I guess. All right. Okay, so any question related to the quiz? No? No, I guess, all right. All right. By the way, is everybody okay? It feels like it's just me talking and everybody's asleep. So I want to check that everybody's following me. No, nothing. All right, following. No. Okay. All right, good. All right, my throat is very dry, so I just gotta take a sip from coffee. Okay, so recap session is done. So let's move on to the next section. How do I? All right, clear. All right. So okay, so my suggestion is, because naval engineers are generally less familiar with basic ML, I would suggest that when you form a project group, which will come in the second half of this class, second half of this course, why don't we have a match of one naval engineer, one Chi student? Because Chi students they seem to, at least on the surface, they seem to understand basic ML better, or at least they've memorized basic ML knowledge better than naval engineers. But I'm very sure that naval engineers are much better engineers compared to students because of all the actual practical knowledge and practical practices they have gone through. So maybe it's a good idea to form a group of 2 people, one naval engineer, one Chi student. Just, you know, get to know each other, and then, you know, Chi students probably has a lot of questions to naval engineer, which is like the best IT company in Korea. So they're probably very interested in what naval engineers do. So I think that would be a good opportunity. So this is just a suggestion. We'll think about that over the course of the first half of this class, and when the time comes to actually form a group, we'll revisit this idea again. And if you have other ideas or other suggestions, please freely share your ideas in Classroom. Don't be shy. All right. Oh yeah, okay, I forgot about this. So there's a quick survey. I should have done this earlier. So there was some feedback that some people were having a difficult time following the lecture itself because of probably my English, whether it was too fast or too slow. So please visit this webpage now. Okay, okay, I'll just type it here. HTTPS forms GLE DVD QYM9 ANBZX4T68. Please visit this form now and then just do the survey right away. It's just like a 30-second survey so that I can try to control the speed, or either I can repeat some sentences in Korean. Like I can think of an idea. I want to get a general sense of how much attendees are following my lecture. All right, so when you go there, it'll look like this. So how much were you following my English, or basically the lecture itself? And 0% to 100%. And please leave a suggestion if you have one. So I'll give you guys 1 minute. Yeah, I'll give you guys 1 minute, and then I'll just, yeah. Oh, I think this is anonymous, right? Yeah, this is anonymous. So don't worry about leaving your email address there. It's already 9:50. Time really flies. All right, 1 minute's up. So please wrap up your poll, and then wait. How can I see? Give me just a second. All right. Give me just a second. Let me see how I can access the answers from you guys. Okay, so I got 50% of, so half of you understood 100% of my English, which which is great news. Okay, so that's better than I expected. So I guess about absolutely more, majority of the attendees were understanding, like at least 80% of my English. So that is good. I'll try to accommodate for those who have not been very comfortable with my speed or my English generally. So some suggestions. Okay, so there was a suggestion to speak a little bit more slowly. So I'll try to do that. I tend to speak very fast when I give lectures or when I do seminars, because I try to transfer as much ideas and concepts as possible in a limited time frame, but I'll try to keep it a little bit slower, like slow paced, more easy paced lecture. And as there were a lot of suggestions or requests to rephrase or repeat what I said in Korean one more time. So I'll do that. If I can't do that every single time, so I'll try to do that if I think some concepts are tricky to understand. And if there are requests in the chat, I mean, just anytime, please request in the chat for a for repeat in Korean. I can do that anytime, so please do that. Don't be shy. Never, yeah. I want a lot. I hope that like 100% of the attendees understand what I'm saying at each lecture. So please, if you don't understand something, put that in the chat box and request a Korean version of what I said, and I'll definitely do that. All right. Okay, moving on. So, oh yeah, reminder. So I think, how many people are in Classroom now? I think it was 18 as of this morning. 19. Okay, so please, we have 10 students and 12 engineers. So yeah, I think maybe the line engineers haven't joined the Classroom, but please, if you haven't joined, please do, because for security reasons, the head of the department asked that I use different passwords at every class. So I need to do that pretty soon. And I will announce the passwords every single time before the class on Classroom. So if you're not a member of Classroom, you won't be able to access my class, the Zoom class. So please register, or otherwise you won't be able to access. No Classroom, no Zoom access. So yeah, please do. Never forget to check regularly what like if there is any update on class. All right. So today's topic is electronic health records, and I'm not sure if we can finish it because it's already, and we only got 30 minutes. So electronic health record is itself a pretty large subject. It's a broad topic. I'll try not to skip all the details, because this will be the like electronic health records will be used throughout the class as an example for applying various machine learning techniques. So that is why it's today's topic. Like, I won't go into basic deep learning like theories like RNN, CNN, like transformer attention. All that will come later, because when we learn that, we will every single time the examples will be using EHR, electronic health records. That is why today. All future examples will be based on EHR, and we will cover. And of course, gaining access takes time. So EHR is not it's free. Some are free, but you need to request access to either MIT for Mimic 3, or either to Shimpyeongwon, which is Korean organization. So yeah, you can't go to an internet website and then download like instantly. You need to go through a certain process to gain access. So that is why today, because you want to start the request as early as possible, so that at least next week or the week after that, you will have you will get your hands on EHR and actually see the EHR yourself. So today's topic will be Mimic 3 and Korean national insurance claims. This is Shimpyeongwon dataset. This is Mimic 3 is Mimic 3. All right. So starting with Mimic 3. So Mimic 3 is records from intensive care unit. It's 중환자실 in Korean. So when you're really sick, like you're dying or you're unconscious, you're like transferred to the ICU, intensive care unit, and then you have all the machines like sensors and blood pressure and all that, like like gadgets and devices attached to your body to monitor you 24/7. So, and you lie in bed basically. So Mimic 3 are records. It's a collection of records from intensive care unit. It comes from Beth Israel Deaconess Medical Center, which is located in Boston. And it is open, so the records come from this hospital, but the open source was done by MIT people. And the reason is that it's pretty interesting. So let me share my desktop actually. So think I have opened it. Yeah. So this is Boston. This is, wait, am I sharing my? Yeah, I'm sharing my desktop. All right. So this is Boston. This is where Beth Israel Deaconess Medical Center is. It's right at right, like not right across MIT here. So MIT is here. Beth Israel Deaconess Medical Center is here. So it's right across the Charles River. So that is why you can see the physical proximity. Really, the closeness of two organizations really helps collaboration. That is why they decided to ask MIT, or maybe MIT asked the BIDMC to open source their data. So, and nowadays, Mimic3 is one of the only two data sets that are openly available. Two EHR data sets that are only two publicly available EHR datasets, and both are open sourced by MIT. And you can see that if you're interested in healthcare, you have to use Mimic3 at one point or another. So Mimic3 is becoming the standard of EHR, which is not very optimistic for like people like us in Korea, because again, like the standard is coming from the United States. So, but at the same time, we're very thankful that they actually did open source EHR dataset, or otherwise nobody can actually really do healthcare research without actually collaborating or partnering with a hospital. So yeah, and all right. So moving back to this, so Mimic3, it consists of over 40,000 patients, and it's been collected between 2001 and 2012. So it spans over 10 years or so, and it contains vital signs, lab test results. Lab tests being like urine tests. You pee into a cup, and then they take that cup to the lab, and then they analyze it, or genetic sequencing can be also like a lab test, I guess. What else? Allergy tests. That is like a lab test again. So there are a lot of lab tests, and medications is the drugs that you take. Caregiver notes. Nurses or doctors will like put notes in the charts when you're lying in the bed. So caregiver notes are so there. Imaging reports. So when they take like X-ray images or CT scans or MRIs, the reports of that image are contained within Mimic3. Not the images themselves. Images are different issue. So Mimic3 doesn't have images, but has imaging reports. Mortality. It means that whether the patient died within the hospital or not. And the reason that it is Mimic3 is because there were Mimic2 and Mimic1. And as there were updates, like moving from Mimic2 and Mimic1, Mimic2, Mimic3, they're increasing the size of the data set, basically. They're either they're cleaning up the database, or they're adding more patient records, or they're merging patient records into a single like database, trying to again clean up the variable, clean up the schema again. So Mimic 1, 2, 3, we live in the era of Mimic3. I think Mimic 4 is coming pretty soon, and we'll have to adapt to the new format when Mimic 4 is announced. So okay, so that's Mimic3. That's like the overview. That's like the overview description of Mimic3. Accessing Mimic3 is kind of it's not complicated, but it takes some time. So you have to go here. I can do a basic demo. So requesting access, you go here, as I said, and then you can see a pretty a detailed description of how you can gain access. First, what you need to do is you need to complete a training, which is called a city training. So city, yes, it's called city program, and it's a certificate of that you've gone through basic training for dealing with or handling human or private data. Basically, you're handling human related data or private data, and you've gone through enough training exercise to understand the implications of handling EHR so that you are good to go. So you need to get city training. So here you can do city training at this right here. And I've already finished this, so I can show you exactly how, but maybe, actually, maybe I can ask the TA, the head TA of this course to follow this. So Yongshik, are you there? Or wait. Okay, that is unfortunate. Or is Mingi there as well? Mingi TA? Oh, okay, so, good then. Could you access this? Could you show a demo of how you can register yourself to a city program and then go through like and register yourself for a basic the training? Let me see how you can access this. Can I send a private message or? Really? I can, okay, I can type it here, HTTPS. All right, please, yeah. So Mingi, please click that and then I'll stop sharing my screen and you can start sharing your screen so that you can show everybody how you can register yourself to the city training. So, all right. Mingi, could you share your desktop? The reason that I'm asking the TA Mingi to do this for me is because I already have registered myself to a city and I've finished my training and I have the certificate, so I can't show you step by step how you can register yourself. Cool. Okay. Now, if you can scroll down a little. Oh, there's a. I think you missed the link. 좀만 위로 가주실래요? 그 CT 트레이닝 링크 보이는 곳으로. 예, 그거, 예, 그거. 네. And if you click the empty box there, yeah, type in Massachusetts, basically MIT. So type in MASS, MASS. Yeah, and select the one that says Massachusetts Institute of Technology affiliates, the fifth one, the affiliates, yes. And then agree. Again, then agree. Right, and then yes, continue. Yeah, fill in the information. Yeah, you can click no to all of that. Yeah. That's all no. Yeah. No. You click no, so that's yeah. Yeah, there's only one English. Cool. Okay, so this is important. Selecting curriculum. I'm not able to. I'm sure in. So what you need to select is human subjects training category. Yeah, in that human subjects, there is a one called data or specimens only research. Yeah, that one. So we need to click that. Okay. And then question 2. Select the group for which you have previously completed. You have not completed anything, so that's okay. So yeah, the last one. Yep. Would you like to take no? We don't know French. Responsible conduct a research course for enrollment. It doesn't. Give me just a second. Select. Yeah, it doesn't say anything about this, so no thanks. Question 5. Nope. Nope. That is also. You don't apply for anything. Yeah, we're not doing annual research, so that's okay. So skip all of that. And question 8. Please make the appropriate selection if you're required to. No, not at this time. We are not like practicing medicine, so that's okay. Okay, complete registration. So selecting the right course is absolutely important. 꼭 저거 하셔야 돼요. 지금 이 조교님께서 하신 거 그대로 따라 하셔야 됩니다. 안 그러면은 잘못된 코스 들으시면은 나중에 그 Mimic 3 액세스 안 돼요. So as I said, please follow the steps exactly like this, because if you choose a wrong course, then you won't be able to access Mimic 3. Or you can, but you'll take way more time. So, what happens if you finalize registration? Okay, institutional course. Let's go down a bit. Okay, so let's view the course. 쭉쭉 내려가시면은 네. 네, 9개밖에 없네요. 9개면 나쁘지 않네요. 제가 예전에 할 때 막 20 몇 개 했었는데 하여튼 이걸 클릭하면 스타트 한번 클릭해 보죠. Yeah. So there are 9 modules that you need to complete. Agree. Yeah. So this is pretty, it's not very exciting. If you click start, what basically you need to do is you need to read all that and then answer questions. And it's not a very fun read. This is like, yeah. The Belmont report is like the one that set the foundation of all the like privacy and all that. So down, please, down. Yeah, so there's a quiz. So you are supposed to read the Belmont report and then take the quiz, which is not very fun. And then you need to get a certain level of score in order to qualify, in order to pass this module. So this was Belmont report module, and you need to take the quiz and then get like at least 80% right or like 90% right to pass the module. And I should tell you that there is no penalty for trying multiple number of times. Okay, so you can take the quiz and it's okay to get wrong and then try again. There is no penalty. So what I would do is that I would just solve the quiz and then do trial and error. But this is like a hack. So correct way to do this is read the Belmont report and then solve the quiz. But I'm telling you that there is no penalty for trying out the quiz multiple number of times. Please repeat the answer of the first question. I just missed it. Could you please repeat it? No, there is no, I'm not giving you the answers. This is something that I don't even know the answer, actually. I forgot. So I'll just repeat this in Korean again. 이게 실제로 이 퀴즈를 이 CT 트레이닝을 제대로 하려면 아까 9개의 모듈이 있었는데 그거 하나하나를 다 들어가시면 이렇게 뭘 읽고서는 그거 읽은 걸 바탕으로 퀴즈를 풀어가지고 퀴즈에서 뭐 예를 들어서 60% 이상, 80% 이상을 얻으셔야 되거든요. 근데 이걸 읽는 게 정말 쉽지가 않기 때문에 제가 말씀드리는 거는 제대로 그러니까 읽고 풀어야 하는 게 맞지만 퀴즈를 여러 번 푼다고 해서 페널티가 없어요. 그러니까 퀴즈 100번 푼다 그래서 그전 거 뭐 그전에 빵점 맞았다고 해서 다음번에 100점 맞으면 뭐 페널티 있고 그런 거 없어요. 그냥 한 번 여러 번을 시도하든 단 한 번만 하시면 됩니다. I think this question is related to registration. Could you repeat the answer of that? Human subjects. I'll actually 제가 이 코र्스 매테리얼 아니구나. 그냥 여기에 제가 써드릴게요. 여기 보면은 나중에 요거 녹화된 거 올릴 테니까 그거 참고하셔도 되고요. Data or specimens only research. And with private data, everyone. 다시 data or specimens. 요거 선택하셔야 됩니다. Data or specimens only research. 그리고 제가 방금 말씀드렸듯이 퀴즈를 여러 번 해도 상관없으니까 퀴즈부터 풀고 트라이얼 앤 에러를 한다 그래도 네, 뭐 막을 방법 없다는 거를 말씀드리는 거예요. 하지만 제대로 하려면은 당연히 이걸 읽고서 풀어야 됩니다. 네. 네, 그럼 이제 한 몇 시간 걸릴 거예요, 적어도. 하여튼 네, 그렇게 해서 okay, I'll return back to English. So once you took the quiz, okay, so Mingi is showing demonstration. Good. So if he does that and submit, well, let's see what happens. Incorrect. Incorrect. And you can see the correct answer here. So if you get it wrong, there are correct answers shown. So you can imagine what you should do, given that when you get it wrong, there are correct answers given, and there's no penalty for trying out multiple times. In Korean, 틀리면은 정답이 나오잖아요. 그리고 여러 번 퀴즈 풀어도 되잖아요. 그러면은 뭐 아주 빠른 시간 내에 끝내실 수 있겠죠. 네. Okay, so okay, so once you've could you go down to the bottom of the web page, please? Okay. It's not showing yet. But once you finish all the 9 modules, you will be able to access a certificate. It's a city certificate. It's like a graduation certificate, which says that you have finished the data or specimens only research training. You need that certificate in order to access Mimic3. So okay. Could you stop sharing your screen, Mingi? All right, I'll return back to my screen then. Okay, so you need this certificate, data or specimens only research certificate, so and in order to access Mimic3. So, oh, actually, maybe I should have let Mingi go on. So in order to request access for Mimic3, you need to go here, which is PhysioNet, and then you, again, I've already registered myself, but it's not that difficult. You register yourself to this website, PhysioNet, and then you need to follow this step and find the file section, and then click credential user, because you have credential. You're using city completion report, which is the city certificate. So you need to follow these steps, provide the city certificate when you're trying to request access to Mimic3. And when your application has been approved, you will receive emails containing instructions for downloading the database. So when you have gained access to Mimic3, you will see something like this. Give me just a second. PhysioNet. Downloading the database. All right. So when you have gained access, you will see a bunch of files at the bottom of this page. I've just clicked this one. So here, getting started. Requesting access is where you can see all the information about requesting access. Downloading the database is where I just click this link. And when you have gained access, when you don't have access, when you haven't been granted access, then you won't be able to see the files section. But when you have gained access, then you will be able to see the files section. And then there are a lot of tables, like admission table, call out table, here, like 25-ish tables that you can download. All right. So in Korean, 요 CT certificate, CT 트레이닝 아까 퀴즈 다 푸시고 다 그 9개 모듈 끝내시면은 요 CT certificate을 다운받으실 수 있거든요, PDF로. 그럼 그거를 가지고 여기 가셔서 아까 여기 가셔가지고 네, 근데 여기 가셔서 이제 등록하시고 이제 그 유저네임 등록하시고 그 다음에 등록하신 다음에 여기 시키는 대로 요 파일 섹션 가가지고 크리덴셜 유저 링크 누른 다음에 거기다 이걸 업로드 하셔야 되는 거. 아까 그 받으신 CT 서티피켓을 업로드 하면서 Mimic3 액세스 하고 싶다라고 하시면 되고, 그때 액세스 하실 때 중요한 게 요 제 그 supervisor name을 provide 해야 되거든요. So if you are a student or a postdoc, you must provide your supervisor's name and contact information when you're requesting access for Mimic3. So when you request access to Mimic3, you upload your city certificate and you provide my information. So here, you need to provide supervisor's name and contact, which is Edward Choi, my email, and my my phone number. I'm not sure if they require phone number, but if they do, just use my phone number. So do that. So yeah, okay. So it's already 25. So I think our time's up today. So okay. So there are a bunch of things that I prepared for today, but I guess we'll have to skip that to the next, delay that to the next class. So recap of today is please complete your city training, and with the city certificate, please gain access to Mimic3 so that you'll have access to Mimic3. When you do have access to Mimic3 and you have downloaded the tables, what you will see is, for example, I downloaded my table to here, and then I've only downloaded like 10 tables. There were 25 tables, but I only downloaded 10. And if you see the table, it's basically a CSV dump file. So This is like all about admissions, like when the admission happened, who was admitted to the hospital, and like when, like what was the reason, like was it emergency, or what, did the patient come in their own, like voluntarily, like all kinds of information about the admission. And patient information, you can see like if they're male or female, like when they were born, like times, and what if they died in the hospital or not, like various information about the patient. So you will get access to that, and then we can do fun stuff with it. So okay, assignments. Complete your city train. This is the first. So there, I said there will be 3 assignments. This is number 1. Complete your city training, gain access to Mimic 3, and download all Mimic 3 tables to a local drive so that you can play with it. So do this, and there's a submission required. You need to submit your city certificate, due date March 23rd, basically midnight, and send the email to me. Don't send that to TA. Oh, you can do CC on TAs, but please send those emails to me primarily. Include your name and your student number and the city certificate, the PDF file that you downloaded from completing the city training. So do that. Attach your city certificate to the mail and send that mail to me by March 23rd midnight. So that'll be, if you submit the right one, then that will be perfect score for the first assignment. So do that. Please do that by March 23rd, and don't just finish the city training and be done with it. Please complete the training, gain access, and download everything as soon as possible. Because all our future examples and future assignments will depend on you gaining access to Mimic 3. So please do that before next week. I can't ask you to share. I can't ask you to download Mimic 3 and then attach a sample of that for proof, because you can never share private information, EHR, to other people. Okay, don't do that. This is for your research purposes only. So don't do that. We'll talk about the identification and all that, privacy risk and all that in the next class. All right. So okay, so it's 10:28. Please, if you have any question, please do ask them now. If you have any question, ask them now, or ask them on ClassUp. If you have any trouble finishing the city training or gaining access to Mimic 3, do not hesitate to post your questions on ClassUp, or send me or to the TAs your emails. Okay. All right. Okay. So thank you very much for today's course, everybody. I'll see you guys next Tuesday. And before that, again, register yourself to ClassUp and complete your city training, gain access to Mimic 3, download your Mimic 3 tables. All right. Thank you very much, Bob. Everybody. Bye-bye. Bye-bye.